Hey everybody, today we're going to be looking at quadratic in nature or U-substitution. So U-substitution is a very powerful tool in mathematics, and it's kind of one of those tools that's like a trick that makes things work that feel like they maybe shouldn't work. But again, it's a really nice tool, and it's used especially in calculus a lot. So if that's the kind of trajectory you're planning on going down, is going that calculus route, this is going to be a very, very important tool for that work. So getting into it, we're going to start off by looking at equations that kind of feel like they should be quadratic equations. Okay, now remember, a quadratic equation is something like ax squared plus bx plus c equals 0. Okay, and if I look at this equation, it kind of feels like that. I've got an x squared, or I've got something that's being squared. I've got something that is the same thing, right? The x and the x. Okay, and I've got a b and a c. It kind of feels like this should be some sort of quadratic equation or formula. So let's look at how we would want to deal with this, because one way we could deal with it is we could distribute everything out, combine things, and then it would be a quadratic. But that's a lot of work. There's a lot more involved in that process. So what we're going to do is we're going to do what we call U-substitution. Okay, now U-substitution says basically I'm going to take a piece of this and I'm going to say, instead of it being that piece, let's let it be U for just a little bit. Okay, so the piece I want to choose is the piece that's going to make it look like a quadratic equation. So in this case, on this one, what I want U to be is I want it to be 2x plus 5. Okay, and I'm choosing that somewhat arbitrarily, and as you do more of these, you're going to start seeing that pattern of what you really want to choose. But the reason I want to choose that is because now if I go in, and everywhere I see 2x plus 5, I put a u, then it's going to look like this. I'm going to have u squared, right? Because I had 2x plus 5. I just put a u in there with the square. Minus 3. Okay, got another 2x plus 5. I'm going to put a u. Minus 40. Okay, and what this does, and it's still equal to 0. Okay, and what this does is it says, okay, now it looks like a quadratic equation. The only difference is we have u's instead of x's. I can factor this out. U minus 8, u plus 5, okay, which then means u needs to be positive 8 or negative 5. Okay, well, that's what u needs to be. The problem is I need to know what x is. Okay, well, but now I know what u is. So I should be able to take this u and plug it back in to the u that I had before. Okay, now I have to do it twice because I have two answers. Okay, but that's fine. So I'm going to take that 8 and I'm going to plug it back in for you. So 8 is equal to 2x plus 5 minus 5 minus 5. 3 is equal to 2x. Divide by 2, divide by 2. So x is 3 halves. Okay, and then same thing with negative 5. Negative 5 is equal to 2x plus 5 minus 5 minus 5. We're going to get negative 10 is equal to 2x. Divide by 2, divide by 2. So x is also equal to negative 5. Okay, now we can always go and check our answers. Okay, and one way we can check our answers is to plug these in. But this 3 halves is going to be kind of a pain to plug in. The negative 5 wouldn't be too terrible. The 3 halves is going to be kind of a pain to plug in. So let me show you a trick. And I've been kind of saving this for the end of the year for you guys. But keep in mind, I do need to see your work on these problems, especially on these problems. Like, there's no way that you're doing these in your head. So please make sure you are showing your work. And feel free to use what I'm about to show you to check your answers. Okay, and again, I want to be very clear that this is a tool to check your answers, not get the answers for you. The goal here of this lesson is to practice that U substitution. Okay, so I'm going to head over to Desmos, and I'm going to graph that equation. So I do want to go into the graphing calculator. Okay, and what this is going to do is it's going to give me those x-intercepts. So I'm going to say y is equal to, okay, and I'm just replacing 0 with y, 2x plus 5 quantity squared minus 2x plus 5, okay, minus 40. Okay, and then I can go here and I can click here. Okay, there's that -5 that we got. And I can click here. That's that 3/2 because 3/2 does simplify down to 1.5. Okay, so again, this is a good way to check your answer. Again, I want to be very clear that we are checking our answer. We are not just using this to get a free answer. Okay, I do need to see that work on this section. If I don't see the work, then I'm not going to give credit for that. Okay, so just as a heads up. Okay, now it's not always as easy as going, okay, well, it's super obvious. Because on this one, it's less obvious what my u is. We also have another problem here. Okay, on my last one, I had it equal to 0. Okay, which I need it to be equal to 0. So first step on any of these problems, make sure it's equal to 0. Because if it's not equal to 0, that's going to cause us problems later. So I would go ahead, very first step, step 0, we'll call it step 0, get it equal to 0. Okay. So I'm going to add 6 to both sides. And I'm going to get 1 over 2x minus 1, quantity squared, plus 5 over 2x minus 1. I'm going to put that in parentheses. You'll see why in a second. It's going to make our life a little easier in a second. Plus 6 equals 0. Okay. Now I'm going to rewrite this slightly. I'm going to say 1 times 1 over 2x minus 1. Okay, and I can do this because 1 squared is just going to be 1. Okay, plus 5, 2x minus 1. Okay, and if I redistributed that 5, right, the 5 would just end up back just like we had it. Okay, plus 6. Okay, so now again, we have that quadratic in nature. It feels like a quadratic. I've got something being squared. I've got that same something with a coefficient. Okay, so I'm going to choose my u here to be 1 over 2x minus 1. Okay, so everywhere I see that 1 over 2x minus 1, I'm going to substitute in a u. So u squared plus 5u plus 6. Okay, and then we've got that nice quadratic. Sorry, equals 0. We've got that nice quadratic. This is going to factor into u plus 3, u plus 2. Okay, which means my u must be -3 or -2. Okay, now we do want to check these answers, make sure we don't end up with extraneous solutions. Okay, and we do still need to figure out what x is, not what u is. Okay, so I'm going to plug those u's back in. So -3 is equal to 1 over 2x minus 1. Okay, again, I'm just taking that u, I'm plugging it back in. Multiply both sides by 2x minus 1, 2x minus 1, cancel, cancel. Okay, so I'm just going to flip the order on these. It's just multiplication. I can do that. So I get -6x plus 3 equals 1. Move that 3 over. Divide by -6. So then x is about 1/3. Or is 1/3, I should say. It's not about. Okay, doing the same thing for -2. So -2 is equal to 1 over 2x minus 1. Multiply both sides by that 2x minus 1 and put it in a better order. So we're going to say -2. 2x minus 1 equals 1. Okay, and again, these are canceling, right? That 1 stays. That's why there's a 1 over on the right. So -4x plus 2 equals 1. -2 minus 2. -4x equals -1. divide by -4 on both sides. So then x is also 1/4. Okay. And again, please do use Desmos to check your solutions. Okay, make sure they work. So heading over to Desmos, I'm going to type this one in. Okay, now I do need to type it as this one. I want to type in this one. Okay, I don't want to type in this because that -6 is important. I need it to be on one side. Okay, so I do want to type in that new one there. Okay, so let's erase this one. And we're going to say 1 divided by 2x minus 1. We're going to do quantity squared on that. Squared. Okay, plus 5. Okay, the important part here is to really make sure you're typing these in correctly. Otherwise, it's not going to work nicely for you. Okay, and then plus 6 because we moved the 6 over. Okay, and now remember our numbers were kind of like in here, so I'm going to zoom in a little bit. Okay, and we can see that it does in fact cross in those two spots. This is kind of an interesting graph too because it moves over, drops down, and that line is actually there. That line right there is actually there. I know on the calculator sometimes we'll go, okay, that line's not really there. But remember, Desmos is super accurate when it comes to this stuff. So if it's there, it's there. So this is an interesting one because it drops down and we don't actually end up with an asymptote here. We end up with some holes. And this is kind of an interesting graph because of that. Okay, so, or cancel. Next one. Okay, it's the same idea. Now this one's a little tricky because I don't see a squared there. But if I think about it, okay, so first off, we do want to move that 20 over. So we're going to say x, oops, not squared, plus square root of x minus 20 because we do want it equal to 0. Okay, but if I set u, because u is always just kind of that middle term, right? If I set u to the square root of x, well then u squared is x, because if I square this, right, it's going to turn into x. The square root will cancel out. So actually I do have that here. We're going to say u squared plus u minus 20 equals 0. U plus 5, u minus 4. So u is equal to -5 or positive 4. Okay, plugging that back into what u is, and it's not u squared, it's u. Okay, I'm going to say -5 equals square root of x. I'm going to square that, but hold up, wait a second. Okay, I can't ever have this happening anyway. Okay, I can't, when I take a square root and it's already in the equation, and this one was there, we didn't force this one, I don't end up with negatives, I only end up with the positive. Let's go ahead and do it though, just to check and make sure, but this one shouldn't work for us. So I'm going to say x is equal to 25. Okay, doing the same thing with 4. Square root of x is equal to, x is equal to 4 squared, so x is 16. Okay, so again, let's head over to Desmos, check those answers. So we got x plus the square root of x minus 20. And now these numbers are way over here, so we're going to move it over a little bit. Okay, we do end up with a 16, and then 25 is up here somewhere. Okay, so we can see that again, 25 didn't work, it was at 10. Okay, so again, we know that is a solution that's not a real solution, so it is extraneous. So we're going to get rid of that one. X is only 16. Okay. Again, not always immediately obvious, okay, but take a second and you should be able to figure it out. I can't pause. You have to come back.
Yeah, no, I'm used to it.
Okay. So it's going to be x squared. Oh, we're already equal to 0, so that's nice. Okay, so let me go back. So we're going to set u equal to x to the third here. So then we get u squared, right? Because if I squared this, it would be power to a power we multiply. plus 9u plus 18 equals 0. Factoring, we're going to get u plus 3. Hold up, sorry. Brain fart. Nope. Yeah, u and then u plus 6. Okay. Equals 0. So u is equal to -3 or -6. Okay, going back to here. So then u is equal to, or sorry, -3 is equal to x to the 1/3. Okay, we would cube both sides here. Get rid of that third, right? Because that'll cancel. So we get -27 equals x. Okay, doing the same thing with 6. We're going to get -216. Okay, going over to check that. Come on, thank you. Okay, so we have x raised to the 2/3. Okay, and again, make sure we're putting it in Desmos right, because if you don't put it in Desmos right, then it's just going to give you the wrong answer. 9 raised to the 1/3, and then plus 18. Okay, now we had 1 at, oops, sorry, not 9, x. Yeah, make sure you're putting it in right, otherwise you're not going to get the right thing. So x to the 1/3. Okay, so we had a cross at -27 and -216. So let's check out -27. Did I type that in right? I did not. That's why it's not giving me that. There we go. That looks a lot better. Okay, so -27. Okay, we have one. Now we're going to have to zoom way out to grab that other one at -216. So let's just go over. And it does look like it's crossing somewhere over there. So click that line. And it is, in fact, at 216 as well. Okay. Last one. This is a quick one. So sometimes, again, we don't necessarily need to use U-substitution. It feels like maybe something should work, but we don't really need to do it. I'm going to set this equal to 0. 4x cubed, we're going to subtract 8x squared from both sides. Minus 8x squared equals 0. Okay, on these, I can factor out a 4x squared. That's going to leave me with x minus 2 equals 0. Zero product property works even if you don't have these factors, these x pluses or x minuses. Okay, if this x is 0, 4 times 0 is 0, times anything is 0. Okay, so this one's going to turn into x equals 0. Okay, and then this one's going to turn into x equals positive 2. Okay, and again, we want to go check that, but we do want to put it in this form into Desmos. So we're going to say 4x to the third minus 8x squared. Okay. And then we are moving back over to 0 and 2. Okay, which if I look, probably looks pretty good. Yep, and we're good on both of those. Okay, so that is it for U-substitution. Please make sure you do your assignment. Please do make sure you're asking for help. This is a tricky topic. It's not always immediately obvious what you set your U equal to. So if you have a question about that, please do reach out to me, and I will get back to you as quickly as I can. Again, please make sure you're showing work. If all you have is answers on these, that's not reasonable. Okay, there has to be work on these. I cannot do these in my head. Okay, so please make sure that you are showing your work on these problems. Okay, I will see you again next time. Please again get your work done, and we'll get through this.